Hello everyone, my name is Anvita Bansal and we are back with another lecture today. The problem that we are going to discuss today is largest sub-array with zero sum. So let's see it in a sheet. So this is the problem from your SDE sheet that we are going to solve today. Let's have a look. So the problem says that you are given an array having both positive and negative integers. Your task is to compute the length of the largest sub-array with sum 0. Okay, so you're given this test case and the output for it is 5. It says the largest sub-array with sum 0 will be -2, 2, -8, 1, 7. So let's understand how we need to solve this problem, and I'm very sure that once I start discussing, you'll yourself come up with the solution, because the concept that goes behind, or the logic that goes behind this problem, we have already discussed in our previous lectures. So let's have a look. I've already written these two test cases from your problem, and let's try to understand it. So what does it say is that you need to find the length of the largest sub-array with sum 0. So they say that the subarray from here, let's see, the subarray from here till, I guess, here, let's compute the sum. -2, let's, 1 second. So if I compute the sum as per them, as per the solution, what is the sum of subarray from index? This is your index 0, this is your index 1, 2, 3, 4, 5, 6, 7. So let's compute the sum. If I were to compute the sum of this, it is -2. -2 plus 2 will be 0. 0 minus 8. 0 minus 8 will be -8. -8 plus 1, -7. -7 plus 7, 0. So basically, if I compute the sum from here till here, your total sum of the subarray is 0. Do you see that? What we did, we simply calculated the sum of all the numbers from here till here. And as in when we got 0, we understood that it is from here till here, the elements are such that we get a sum of 0. Now, how can we solve it in one pass? One method that's a brute force approach that might come to your mind is that for each sub-array, calculate the total sum of all the sub-arrays. For example, 15 can be one sub-array, right? 15 and -2 can be one sub-array. Then 15 minus 2, 2 can be another sub-array, and so on. 15 paired with all the subsequent elements can form sub-arrays. Then if let's say -2 is one sub-array, -2 and 2 is also one sub-array. Do you see that sum of this sub-array is also 0? But why didn't we consider -2 and 2 as the length of longest subarray with sum 0? Because the question says that you need to return the length of longest such subarray whose sum is 0. So when I keep on calculating for each subarray and all those subarrays which give me sum 0, among them, I will keep a max count that will store the maximum length. So far, let's say I have got maximum length to be 2. But as in when I compute this subarray, I will see that maximum length comes out to be 1, 2, 3, 4, 5. So it will be replaced with 5 and I shall return the maximum length. In this test case, you will not find any other subarray which is of length greater than 5 and has a sum of 0. If you see here, this subarray from this length till this length is also giving you sum of 0. Why? -8 plus 1 plus 7 is also 0. But the length of this subarray is 3. So you don't want to return that. Understood? So first brute force approach can be that you calculate the sum of all the subarrays. So the outer loop starts from 0, goes till last index n minus 1. I have written n, this is exclusive, right? Then another subarray nested within this starts from j equals to I plus 1th index, right? That is like with 15, for 15, all the subarrays that it can form, I calculate the sum. Then same goes with -2, then 2, -8, and so on. So you'll have so many subarrays. and it goes also till n minus 1th index. And what you calculate? You calculate sum, that is like the cumulative sum again, sum plus equal to ARR of I, right? And what is that sum basically? For that sub array, not exactly ARR of I. If you are calculating, let's say it's 15, I is equals to 0, j is equals to 0. Sum is what? 15 itself. Then you calculate the length. How do you calculate the length? You will check j minus I, or you can do j minus I plus 1. That's how you're calculating the total length. Understood? So for example, if your I is 0, j is 0, your sum will be 15. Then you increment the count of j, it will come out of the loop. Then I starts for 1, j starts for 1. Actually, for I0, it will go from 0 to n minus 1, and you will keep calculating. First, it will be 15. Everything that I showed you here, right? So that in brute force will be something like this, and the time complexity of it will be for each element. For each ith element, I am calculating for n minus 1 elements, and how many elements are there to process when we are running a loop of index I, total n elements, right? And we are calculating for n minus 1 subsequent elements to form the subarray. So it will be O of n square of time complexity. If I were to talk about it, let me see if you guys can see my screen also or not. Fine. So this is about the brute force approach. The issue with this, I'm not means although I've discussed almost everything about the brute force, but I'm not getting into details because we have discussed this a lot of times, and why the time complexity is n square and why we go to the optimized approach. Now let's see if we can solve it using some other approach. I'll show you a pattern here. Keeping that cumulative sum in mind, I think you can recall your cadence algorithm, although it's somewhat using the cumulative sum. That's what we do in cadence algorithm, and then using some trick, not exactly trick, some condition to stop that cumulative sum in order to get the answer. What are we going to do here? Again, just keep focus on how we're calculating the cumulative sum, and do you see some pattern on which you can apply a condition to get the answer for maximum length? Let's have a look. So if I were to calculate the cumulative sum, the sum for this will be 15. Then next 15 minus 2, 13. 13 plus 2, 15. 15 minus 8, 7. Right? 7 plus 1, 8. 8 plus 7, 15. 15 plus 10, 25. 25 plus 23, 48. Right? So you will say that here, how can we manage to find that which subarray is giving me the sum 0 and which one is the largest one? How are we going to keep the track of that? So for that, I just want you to have a look here. Have a look here for something that I want to show you. That something is basically nothing but graphical representation of how these sums are varying. How our sum is varying? See, let's say for example, in the beginning my sum was 15, somewhere here. Then my sum went down to 13, right, somewhere here. Then my sum again became 15, somewhere here. Then my sum came down to 7, let's say somewhere here. This is, let me write also, this is 15. This is 15. This is 13. This is 15 again. Then this is 7. Okay. I'm showing you the pattern of cumulative sum. Then your sum increases and becomes 8 somewhere. Right? This is 8. Then it goes and increases to 15 again. Okay, this is 15. Right? Then it goes to 25. Let's say this is 25. And then it goes up till 48. Let's say this is 48. So this is the pattern of your cumulative sum, right? Do you observe something? So what does this each edge represents? Each edge represents all the elements that are counting up to give us the sum of from here till here. So let's say initially the sum was 15. Then I added some elements which definitely must be negative also. That is why my sum is going down. So my sum goes down due to certain elements. Then sum goes above again and becomes equal to sum that I found earlier. That simply means that elements from this index till this index are collection of positive and negative integers such that adding them gives me same cumulative sum. It means that they are coming out to be the sum of 0. You getting this point? If let's say I start from some element here, in between how many number of elements are coming, we are adding them. Then I'm adding all the elements that are coming from 15 to 13. I'm adding all of these elements, and obviously these elements going down coming up means they are adding to sum, make sum of 0. That is why my cumulative sum is equal at these positions, right? So obviously a sub array from this index, so 15 corresponds to which index? This corresponds to index 3, 4, 5, 6, 7. So this 15 corresponds to index 2 and this 15 corresponds to index 0. So this tells me from 0 to 2, I am getting elements whose sum is 0. So if I check from 0 to 2, I see I get elements minus 2 and 2 whose sum is making it 0. So basically, when you check the element from this index, basically you are getting the equal cumulative sum at this index and this index. So the elements from this index plus 1 till this index inclusive are making sum count to be 0. So this is one sub array. So what is the length of this sub array? That will be this index, this idx minus this idx. So what is this idx value? This is 2. And what is this idx value? This is 0. So 2 minus 0. First, let's say the length I am getting is 2 right now. Okay, coming ahead. Now there are certain elements whose sum is coming down to make it 7. Then there are some set of elements that are making the sum 8. Some more set of elements that are making the sum 15. So I check that I have got 15 earlier also. That means the elements from this index plus 1 till this index are making the total sum 0. 15 minus 15, 0. Right? So the elements starting from next index of this 15 till this 15 are making the sum 0. So what is the length of this subarray? So the length of this subarray will be from here till here. See, you are, as much as you are going down, you are going above. That means your sum is total cancelling out. So these are the elements in the subarray whose total sum is 0. We are evaluating this on the basis of observing the cumulative sums. As and when I see a cumulative sum that I have found earlier also, which means there are certain set of elements between that cumulative sum index and this cumulative sum index, which is coming out to be 0. And how do I calculate the length? So this 15 is corresponding to which index? This 15 is corresponding to index 5. This is index 5. And earlier I have found cumulative sum 15 at index 2 and at index 0. So basically all the elements from here till here. Now you see the elements. I'm sorry. So what I want to show you is that the elements all together from here till here are also a set of elements in this array which is making the total sum 0. It decreased, it increased, decreased, increased, and all together they are making the sum of 0, because from here also your cumulative sum is 15, here also cumulative sum is 15. Now which set of sub array, which set of elements you should consider to get the maximum length? So obviously I'll check the index of the very first cumulative sum which was found to be 15, and this 15 corresponds to this 0 index and this 15 corresponds to 5th index. So what is the length of elements I'm going to get from here? That is idx, this index minus this index. So it will be 5. So your total length will be 5 and not 5 minus 2, 3. Even if you take 3, it will be overridden by 5, because every time you're calculating max of your max length and your current length that you are calculating. You want the max of that. Okay. So what you observe here is that the elements from here till here are also giving me the, here this is element from 3 to 5th index are also giving me sum of 0, minus 8, 1, 7. Elements from this index till this index will also give me sum of 0. See, you calculate it. 15 minus 2 to 0. 15 minus 8, 7. 7 plus 7, I'm sorry, I have to exclude this first index and calculate the sum of elements from this. And this is the length I am getting by subtracting this index and this index. So minus 2 to 0. Minus 8, 7. Minus 7. Minus 7, 7, 0. So this in itself is giving me sum of 0. So you get this thing. Now how do we solve it? We can solve it using a hash map. Why hash map? Because hash map can keep the track of cumulative sum, which if I find again, I can evaluate at which index I found it earlier. So let's say when I check for first cumulative sum, it was not present in my map. So in my map, it will come as 15 and it will store its index 0. Next time when I see, next time what I get is 13. I store it in my map. It will be 13 and 1. Next time I get 7. Now check these values I am filling on the basis of my cumulative sum. So this is cumulative sum array. We are not going to create a new array. We are just simply going to calculate the cumulative sum and fill our hash map. Next element that I get is 8. 8 is not present. So I fill up 8 along with its index. So at which index I'm getting 8? At 4. 7 I was getting at 3. 1, 13, 15. I'm sorry, I missed something. 1 second. Just see how I am going to fill my hash map. So when I get 15, I store the sum along with the index. Next time I get 13, I store it along with the index. Next time when I see 15, I put a check if hash map already contains it. Since it already contains it, I will check at what index it is. Then from that index, the current index of this 15 is 2. I have not yet put it in my hash map. I'll make the comparison. So what is the length? 2 minus 0, the length will be 2. So let's say my max is updated with 2 right now. Okay. And then I move ahead. I will not put this into my hash map or update this index because the next time, let's say if I get 15 again, I would want the minimum index of 15 to get the maximum length. I hope you're getting this point. So next element I want to evaluate is 7. The index is 3. Next cumulative sum is 8. The index is 4. I'm putting up these values because I have not found them earlier in hash map. So they are the new key value pair that I'm going to store. Now again, I'm getting 15 at index 5. So I will check if hash map already contains it. Hash map says, yes, I am already there. So it will just subtract both the indices and check what is the length I can get. So the length is 5. Then it will compare it with the max length. It is greater than 2. So it will be updated with 5. Okay. And 15 will not be updated with the new index. Next value of cumulative sum is 25 corresponding to its index 6. Next is 48 and the value is 7. So finally, we will return max. That's how we are evaluating the maximum length of the longest sub array with some scale. I return max in this case. So I hope you understood this. If I were to solve it, we are going to simply use one for loop starting from 0 to n minus 1th index exclusive of n. Then in my map, I'm going to store, first of all, let's calculate sum. Sum will be your initial sum, adding the value of your ARR of I. Then I check if map contains sum. If it contains sum, I'm going to update my answer. Let's say there is some max also defined, max is equals to 0. Max should store, as I told you, you will check before you update max. Let's say you store some, you check out that at what index am I getting that sum. So let's say you take some IDX that is equal to map dot get that sum, right? Then you update your max with math dot max of that max of what you need to calculate already what is present. Let's say 2 was already the length, and now the current length that you want to calculate will be your IDX, I minus IDX, right? So that is the current sum that you would want to calculate, and the maximum of these two will be stored in your max. So that is what you do when you get a sum that is already present in your hash map. Otherwise, else you simply put it in your hash map. Map.put. What do you put? Basically, that sum and the index at which you have found that sum. And after coming out of the loop, you return max, right? That's what you do. But what I want to show you is that this will fail few of the test cases. That is what I want to show you through this example. Why this will fail? This will fail for this test case, -1, 1, -1, 1. See, because in this test case, what we want to do is calculate the cumulative sum. This is -1, this is 1, 0, 0 minus 1, -1, -1 plus 1, 0. According to my cumulative sum, I am in my hash map, I am always adding the value -1 and its index 0. This is 0, this is 1, this is 2, this is 3. Then 0 and corresponding to its index 1. These are the map values that I am filling up for you. Now when I am at -1, it will say that map already contains this value. Map already contains this value. So you just calculate the length. Length will be calculated with its index minus this index. And my max will store 2 as of now, right? Because 2 is the maximum I have got. Now next is your 0, 3. Your map will say that this is also already present. You simply calculate the length and update your max. So length will be 2 in this case also, and max was already 2. So your length will not be updated and you will return 2 as your answer. But do you see one thing? The answer in this case should be 4 and not 2. Why? -1 plus 1, 0. 0 minus 1, -1 plus 1, 0. So this entire array is also 0. And this code, this snippet is not handling the case when the length of your array starting from 0th index till some index I is giving all together your sum of 0. We are only calculating the sub-arrays which are basically within your 0 and your n minus 1th indices. And what if you're getting the sum that is 0 including the entire array? It is only giving you 2 length. Why? Because it is evaluating for the sub-arrays within your entire array. But what if your entire array in itself is 0? So what are you going to do in that case? See, actually, when your cumulative sum itself becomes 0, it means starting from 0th index, let's say there is some array A, B, C, D, E, and your cumulative sum is A, B. Here it is 0. Again, it is some X, let's say X, and again it becomes 0. So what does 0 represents? 0 represents that starting from your 0th index till this starting from your 0th index till this index, your sum must have gone up and down or down up like this, and finally they became 0. That means that including that element from 0th index, it is entirely 0. If my cumulative sum is 0 here, let's say -2, 2, no, let's make it -2. Let's make it 4 and then -2 again. So do you see one thing? And then let's say 9, 10, again -90. Let's say this is your array I am giving. So this is -2, -2 plus 4, 2, -2, 0. Which means that if you see, if your hash map will check for this value, it will say that map already did not have 0. So it will not return you this sub-array's length. Why? Because we are handling for only equal sum, cumulative sum cases. But when we are getting cumulative sum itself as 0, that means the set of all the elements till this index starting from 0th index are giving you 0 as sum. So this should be considered, which is not being considered in this case. And let's say keep on continuing, then this is 9, this is 19, and this is 0 again. What does this tell you? If it is 0 again, that means first of all it was 0 here, then it was 0 here. So elements after this 0 are also making a count of sum which is 0. And if you altogether consider this, then also it is 0. But your hash map will return you this length only, this length only, this length. It will say that this is the subarray which you should return, that is of length 3. But it will not understand this case that cumulative sum, if it comes 0 at any instant, this means that starting from 0th index, from 0 till that index, if your cumulative sum is 0, that means all the elements from that index till I are making the sum of 0. So the length in that case should be, what is the length of entire array? 0, 1, 2, 3, 4, 5, 6. So 6 should be returned. And how you will get 6? That will be I minus I plus 1. If I is 5 here, so 5 plus 1 will give you answer. So we will handle this case separately. So you'll add this condition. If your sum is 0, then your max will be I plus 1 comma max. What is the max of these two values will be stored in max. I hope you have understood this one. And then even if you keep continuing this, it won't matter. The max will store the maximum value so far. So let's move to the code and code it. Also, this thing that we have done is taking maximum of how much of time complexity. There's only one for loop where we are making the comparisons. So on is the time complexity, and since we are taking a hash map, and if all the elements are in such a way that you are never getting a cumulative sum of, or never getting a sub array which is giving you a sum of 0, in that case in hash map you will be storing all the elements. So maximum space complexity will also be O of n, right? So time is also O of n complexity at max, and space is also of O n, because we are evaluating for every element starting from 0 to n minus 1. I hope you have understood. So let's, okay, let's create a hash map. Integer comma integer. Int sum, let's take a cumulative sum. Int sum equals to 0 and int max equals to 0 again. Right? Max is the max length. Okay. Max length also 0. Now what next? Start a loop for int I equal to 0, I is less than n, I plus plus. If your sum, this condition we will write after we write other conditions. So what do you check? You calculate sum plus equal to ARR of I. You ask your map if it already contains this sum value. If that is the case, you update your max by calculating the length. So let's say at what index your map contains that sum. Let's store it in IDX map.get sum. And then you, in your max length, you will store math.max of max length comma I minus IDX. I minus IDX is the length that you will get, which will be the length of subarray with sum 0. Okay, fine. Otherwise, if map does not contains, you will simply go and put that sum value and the corresponding index. Fine. That is what you are doing. Now, if your sum is 0, if sum is 0, that is your cumulative sum is 0, your max will store, max length will be math dot max of max length comma I plus 1. That is basically I, that index, minus your 0th index plus 1. That will give you the entire length of that subarray with sum 0. Okay, that is what you're storing, and then finally you will return max. I hope you have understood this problem. That was all about this. It was a nice application of the cumulative sum that we also use to understand Cadence algorithm, right? There, whenever we used to find a sum of 0, that time we used to, in Cadence algorithm, length of longest subarray, right? It is similar to that. So I hope that's clear. And if you have any doubts, you can ask me. Can you elaborate by what you mean no need of keeping 0 in Hashmap? See, if I do not keep this condition, then check your answer. It will fail. Do you see this thing? Exact thing that I explained to you in this example was that it is evaluating subparts of this array, but it does not realize that the entire array itself is giving the sum of 0. That is why your cumulative sum is 0, right? So this is not handled in here. When you try it yourself, you will understand that why this case needs to be, such cases need to be handled like this separately. Okay. So that is all. Fine then, everyone. I'll see you in the next lecture on Monday. Thank you. Bye bye, everyone.